startup. So we're running openwsn, and here we've got a mesh topology. The connection will begin once we set the root node. So we're going to find root node, ideally prefer 0, 0, 1 to be the root node. It'll be somewhere here. Yeah. So we got the address prefix, and the dark root at the moment, as you see, is no. So once we have toggle the dark root, we just clicked it, and here it will change anytime soon. Yeah, to yes. So our root's configured. So our router is ready. Now the node will start joining. Going back to the terminal. Here we are. So it did throw some input-output error, but then it starts begin with the node joining afterwards. So that's no wonder the Python do that. Broken pipe usually sort of occurred when there's an issue with input-output buffer. I think that could be avoided by using Segol import. So here we go. The network is sort of joining. The nodes are joining the root. So the first one's a wrong state, and it started synchronization process and 6 stops scheduling. So 0 is a slot where it's basically a broadcast slot. So every node sort of hear that slot. It's a common broadcast. And on the time it says the time shown on the very left, then shows the info, and then on the third column will be the ID of node. These are sort of hexadecimal numbers, and then that would need to be converted. So we have done that in our plots. So the nodes are joining, and it says number 14 joined, number 25 joined. So it's sort of random. So there's no fixed, because it's mesh topology. And now we're going back to our openwsn here. So this is running in Linux, Ubuntu. We're going back to just sneak into the connectivity, what's happening there. So as we see, we got number 13 connected. We're going to just sort of scroll to the right to find out what other nodes are currently. So the rest of the nodes are due to join, and they will join as we go on. So yeah, routing, we don't have anything so far. We're waiting for routing information, so there's nothing in the routing. It will take some time to sort of configure the network. So this is basically emulation of hardware. Something happened. So it looks like we got more. Oh, there we go. We got a couple of modes now. So as we said, there's no definite there's no, they just join at random, and the nodes sort of use the join proxy. And join proxy is the node that has a minimal rank and sort of a stable neighbor. So it suggests which node the joining node can look for. So it's basically a node that acts as a joining proxy. So here we got the joining proxy through there. So you got 7, and 7 is now sort of hearing from these guys, 00C and 001D. So this is probably going to take a while to get it all connected. So let's look at the routing, what we get in there. Oh, luckily, so we got 4. We so far have 3 nodes that are upstreaming information to the root, And let's just see what happens here. So in the terminal, so it means these nodes, as soon as they join, they start sending. They don't wait for entire network to be sort of synchronized. So they just start sending the packets straight on. And this, as you can see, in IEEE 802.15.4e sync, they're sending packets. They're sending DAO. The DAO is basically a control message, a routing control message that upstream information about the node's location, and that way the root node can maintain the path. So when the packet's it's sent, the information about the path, you see that here, original size 81, so a number of fragment 2, that's the packet. So it's sort of fragmented packets, and it says old fragment that tag 0, so this is a bit of information on it. So this is how it works overall. I can't keep the video so long because it'll be difficult to sort of upload afterwards. So sorry, I'm going to the so as you see in the routing one, we've got a couple of nodes here. So as more and more join, the quickly it gets on and gets more information. So here you see in the connectivity, and here it's getting on really well. So it's connecting using the join proxy. Okay, more information about join proxy and routing is available in the papers. Apart from that, you see there are some of the nodes here at the bottom. Now these are not directly connected to the root, so it's a couple of hops away from there. And how path information is sent, how many hops it takes, that would depend on the information stored by the root and how it has been stored and what sort of path has been stored. So this is how this 50 nodes network works. So I've got 50 nodes in there, and we've got UDP packets running through. So I guess it's 2 packets each second. I'll double check that. So it's the same kind of experiment that we had last. And this is a topology. So that's what we call a mesh topology, and there's just so many links in there, you know. That's one of the weaknesses of it. Drains so much energy. Even bus, you see the information about the node. So we can also sort of open the Wireshark, and you see we can open the Wireshark. It's a good idea, yes. So here we go. We open the Wireshark, and we're going to sort of zep, Z-E-P-C. I'm not sure if it works. So, Wireshark Z. Maybe in cap, sorry. Z-E-P. That's all interface shown. You've got UDP listener, and I've got any, I don't know what that is. So I've got tune 0. So there's basically an internet connectivity via tune interface. I'm just trying to see if I could all interface shown. Wired, wireless, okay. Apply display filter, zep. Why is it not opening that? It could be something to do with configuration, but so as you see, there's a constant movement here, address BB. So that's probably that's the one, and I'm just not able to sort of open that. It's really weird. There we go, lovely. So this is Wireshark, and you see the packets here. So you see the data acknowledgement RPL packet. So here you can distinguish in what packets are being sent, broadcast packets, IPv6, and so this shows enhanced beacons, 6 scheduling as well, how many requests has been sent by which node, whether the schedule is granted or success. So this is just a quick demo of how openwsn works. Ubuntu 18.10. We're using one of the repositories of openwsn that was working earlier with scones. Now we have a different settings, has sort of change, but the firmware is still same, so no matter how you simulate, the results will still be the same. And the scheduling part, we got MSF running right now, so minimal scheduling function, and we have presented some of the results of that into our paper. So I don't know if we could plot these results later on and capture these. So yeah, so far we just got this running. Analyze. I haven't used it quite thoroughly earlier. Just yeah, so here we can sort of see what sort of package you want to. But yeah, we're going to minimize that a bit now. We're going back to original. Yeah, so this is TX BC connectivity again. So this, as you see, more and more nodes are connected, and even that. Yeah, so there's some 0024. These poor guys, they will get connected later on because eventually one of the nodes will find them. So 001C, and so this is how the topology is deployed. So I didn't basically change anything in there on the interface, how topology moves, but yeah, it will join eventually. And routing, you see, if we're in the routing, the current routing information is shown here. So most nodes are sort of available now, and here we go, back to the mode state. And this information here on, as you can see, read and write buffer, exponent back off, ready duty cycle 2.91% on the root mode, keep alive message 10 seconds, I think 10 milliseconds, that's what it was. No, it's 10 seconds. Number of packets, and it's a minimum corrections, so clock corrections to do with the synchronization. If we're looking at scheduling, say TX and RX. RX means reception, TX transmission, and these modes are currently, so it shows what's happening there, how many TX are sent, how many RX are received, how many TX are acknowledged. So this is the information by the nodes. And there's something down here. So here you can see the packet queue. So it shows that packets in there. Right. I hope that demonstration is sufficient for. Yeah. So for just for a demo. Okay. So here we are. So here we go. Let's just see what those nodes. So oh yeah, we're not too far away. So just one. So it's getting closer and closer. So as you see that we had 0024 earlier, and so now it's sort of connected somewhere. Oh no, it's not connected, but it's getting somewhere depending on how the link statistics are. So the nodes are sort of, the topology is moving, so, as you see there. It's moving, and it frequently moves, and when we analyze the result, we find out what all nodes were connected, and so yeah. Okay, don't know if I could take a screenshot of that, but it would be very difficult to capture that bit, because if I take a screenshot, I won't be able to explain which nodes what, because they're all hexadecimal. Okay, so that's not. Yeah. There we are. So it's absolutely no problem, and it's working. You see the reassembly, the timer expired. That's the activities in a queue. Not all packets, retransmittable packets in a buffer. So yeah, I'll leave that running for a while now. We'll see what comes up as a result and how long it sort of runs. Okay,